Vectors Part 3. Scalar multiple of vectors. What do you mean by a scalar multiple? Scalar multiple means a number of times of the vector. For example, if I were to have the vector AB to be 1, 2, meaning 1 unit on the x-axis and 2 units on the y-axis, I will have a vector A to B down here. But if, let's say, I have another vector C to D, and that C to D is 3, 6. What do you notice about this vector? Well, relation to AB. Now the vector AB over here is 1, 2, and this is 3, 6. Observe that there is a 3 times of the column vector 1, 2. Meaning CD is 3 times of the vector AB. If I were to put it in a diagram representation, I will have 3 units on the horizontal and 6 units on the vertical. This one will be C to D. Then this will be 3 units over here, 6 units over here. Now what do you notice about the two vectors? I will have A to B and C to D. They will be parallel to each other. Number 2, if I were to look at the length of AB, taking this to be 1 unit, what will be the length of CD? I will have 3 units in return. This tells us about the magnitude. The length or the magnitude of CD is equals to 3 times the magnitude of the vector AB. So the length is 3 times of the other one. So this is what it means by a scalar multiple of vectors. Now let's explore more into the theory portion. Up next on scalar multiplication, the parallel vectors. Now given that a vector B is equals to k times of a vector k A, where k means the scalar multiplication, constant k, a number of times of vector A. Now there's quite a number of different cases. Number 1, if k is greater than 0, for example, I want to have 3 times of the vector A. This means it's a vector with a magnitude that is 3 times the magnitude of the vector A. And if it's positive, it's going in the same direction. Okay, as B and KA are parallel vectors. What does that mean? So that means the vector B can now be expressed as a number of times of vector A. For example, B equals to 3 times of vector A. Now that is for k greater than 0. Why? Because if the scalar multiple over here is positive, they are going in the same direction. Now, if I were to have a scalar multiple that is negative, for example, if I were to have, let's say, negative 3a, that means it will have the same magnitude, but in negative direction, 3 times of a, the magnitude of A, but this negative tells us that it's going in the opposite direction. So if I were to give you a vector B that is negative k times of the vector A, for example, B is negative 3a. It means I will take vector A, change the direction to be in the opposite direction, and extend it by 3 times. Now what happens if I have 0? Well, this one will be a 0 vector because I will have 0 times a, 0 units of ai, it will be a 0 vector. Let's look at some of the graphical representations about scalar multiples of vectors. Now, what do you notice over here in exercise 1a? Now, if this is the original vector a over here, it's going in the upwards direction. And now, if I were to look at some of the other vectors, for example, if I were to have a positive scalar multiple, 3 over 2 units of a, what does that mean? It means I'm taking a in the same direction, but now I multiply it by a scalar multiple of 3 over 2. That means this whole magnitude, this whole length here, will now become 1.5 times of the length. Right? So that will give me 3 over 2 vector A. Now, if I were to consider a negative vector, okay, what does a negative vector means? Let's say, for example, this is my vector A in the upwards going direction. If I were to have a vector that is negative 2a, that means I'm taking the whole vector, but I'm changing it in the opposite direction, and I'm extending it by 2 times the unit. So the length of A in this case here, and the length here will be 2 times the length of A. Similarly, if I were to have negative half A, I will change the direction, and the length will now be shortened by half. Now this is not very common because in exam they seldom give us such diagrams, but they will give us diagrams in the form of parallelogram or trapeziums, and we need to find out what is the relationship of the different vectors. Now up next, part B, this is going to be quite common. Now we notice that down here they give us 2 times of AB equals to 3 times of BD. It's very difficult to look at the equation just like that. So usually what I tell my students to do is I'm going to write it in a fraction form. Okay, so I'm going to keep AB over here. And this is my equal sign. I'm going to shift BD down. That means it'll be divided by BD. And what stays over here? This is 3. Now I'm going to shift 2 over to the other side now. It'll be going downwards. This is 2. So what does this tells me? This tells me that AB is 3 units and BD will be 2 units. If I were to draw it in a graphical representation, I will have A in 1, 2, 3, A to B over here. So this is probably the vector AB, 3 units. And now I need to draw BD. B is in this location over here. So what does that mean? I need to extend in the same direction. B to D by now 2 units. So 1, 2. So that will give me the point D. B to D is this vector. I know from here I have A to B is 3 units. B to D is 2 units. How many units are there in total here? 5 units. Now, next part of the question asks me to complete the following. So now they want me to find the relationship. How much is AB in terms of AD? Well, I'm going to write it down as AB over AD. in vector form. AB has how many units? 3 units. AD has how many units? 5 units. And I'm going to make a change, shifting in my position. Therefore, AB will be equals to 3 over 5 times of AD. That means this scalar multiple over here will be 3 over 5. Next, they want us to find what is BD in terms of AD. So I'm going to write it in the fraction form. BD over AD. So BD is how many units? BD is 2 units. And AD is 5 units. So now I'm going to shift my AD over. BD will now be 2/5 of AD. And what's the scalar multiple over here in this case? That will be 2 over 5. Now they ask me what is the vector scalar multiple for AD and BD. So I'm going to put AD over BD over here. AD is 5 units. BD is 2 units. So shifting around, I will get AD to be 5 over 2 times of BD. And that answer over here will be 5 over 2. Up next, the property on collinear. What does the word collinear means? Co means cooperate together. So together, okay, linear means comes from the word line. So it means cooperate together to form a straight line. So together they form a straight line. In other words, in mathematical terms, it means the points lies on the same straight line. So that is collinear. Now, let's take a look at the previous example that we have drawn. We know that AB is 3 units, and we were given that BD was 2 units, right? And they share the same direction. They are parallel to each other. So now I know that, number 1, the first fact, that this vector over here is traveling in the same direction as vector BD. So property number 1, they are going parallel to each other because they travel in the same direction. Then number 2, what do I notice when I need to draw this line together? I have a common point B here and another common point B. So if they are traveling in the same direction, they are parallel to each other, and B is in the same point, they share a common point. That means B cannot be in other positions. I will have to shift B and continue B to D over here. As a result, these 3 points A, B, and D now work together and they form a straight line. So therefore, the points A, B, and D are collinear. So this is what the theory means. If I have 3 points A, B, and C, they lie in a straight line if and only if 2 conditions. Number 1, AB is a number of times of BC. This means AB is parallel to BC. going in the same direction, just that they have a different length. And the number 2 most important point, you must share a common point somewhere, such that they force this vector to join in line with the other 2 points. And as a result, the 3 points will now fall in the same straight line. Now let us move away from the theory and try to look at some column vectors and explore the properties of scalar multiple of vectors. Now question number 3 is given that P equals to this, vector P equals to this, and vector Q equals to this, the following, but there is an unknown over here, n. Now they give you that the vectors P and Q are parallel. Find the value of n. Now there is 2 different methods to do this type of question. I'm going to show you the 2 different methods, but you can choose the easier method to do and write down the method that you prefer. Now let me tell you the longer method first, okay, but it's still the concept. Number 1, if 2 vectors are parallel to each other, meaning vector P will be a number of times of vector Q. What does that mean? I will have the vector 8, negative 10 to be a number of times of the vector Q, which is n 15. What is this scalar multiple? It means I will have k times of n, k times of 15. That means I will have 8 negative 10 and k times of n, k times of 15. Comparing the x units with the x units, the y units with the y units, what can I do? I can find negative 10 to be equals to 15k, and k will be equals to negative 10 over 15, which gives me negative 2 over 3. After I know that k is negative 2 over 3, what can I do? I can put it back into my x value. So I know that 8 is now equals to negative 2 over 3 times of n. And after which, I'm going to find what is n. So I shall divide by negative 2 over 3. 8 divided by negative 2 over 3 to give me the number negative 12. Now this method over here involves conceptual understanding of the word scalar multiple and parallel to each other. But it can be a rather long method and we may make careless mistakes along the way. Now what is the easier method to do? I know that if the 2 vectors are parallel, well, parallel lines or parallel vectors, they will have the same gradient. Now, do you remember how to find the gradient given the column vectors? So now we're going to do method number 2 using the gradient. Now, if I have vector P to be 8, negative 10, the gradient of vector P will be equals to negative 10 over 8, taking the rise y value over the run. And in this case, it's telling me that the gradient of the vector P, which is negative 10 over 8, is the same gradient as the gradient of the vector Q. And in this case, vector Q, the gradient will be taking the y value divided by the x value. So that will be 15 over n. Now what do we have here? We have an equation where we can cross multiply and solve for the value of n. So that means I'll get negative 10n equals to 8 times 15, 120, and n will be equals to negative 12. So these are the two different methods. You can choose to write down the method that you prefer. Now, method 1 is on conceptual understanding, and method 2 is on using the gradient. Which method do you prefer? Now, pause the screen and copy the version that you would like to use. Now, let's move on to exercise 3b. 3b is given that AB is the vector 2, 1, and AD is a vector 6, 3. Let's take a look at the vector AB. AB is given to be 2, 1. What do you notice about the relationship between AB and AD? AD is given to be 6, 3. Now, the relationship between 6 and 2 is 3 times of each other. 3 and 1, that's 3 times of each other. That means AD can be written as taking out a factor, a multiple of 3, 2, 1. And that makes me change this column vector into AB. So AD will be 3 times of AB. Based on this, my first conclusion, fact number 1, AB is parallel to AB, and the length of AD, the magnitude of AD, is 3 times the magnitude of AB. Meaning they are going in the same direction and the magnitude is 3 times of each other. At the same time, notice certain things. This is the point AD and this is the point AB. How am I going to draw these two vectors? So if I will have point A to D, and I have a point A to B, I notice that A is a common point. So it forces my line AB to join to be part of the line of AD. As a result, since A is a common point, these 3 points A, B, and D will now join together to form a straight line. So point number 2, fact number 2, since A is a common point, the 3 points A, B, and D are collinear, meaning they join together to form a straight line. So these are the 2 facts about AB and AD. In the next portion, we'll be looking at doing some addition and multiplication of the vectors. Now let's take a look at the following questions. I have the following vectors A, B, and C. Now we're going to do an addition of the vector A, 1, 2, to 2 times vector B, negative 2, 4. That gives us actually 1, 2, plus the vector. Now this is 2 times of negative 2 units. That gives me negative 4. 2 times of 4 units. That gives me 8. And I will be able to get negative 3, 10. And for part B, we have 3 times of B minus 2 times of C. That gives me negative 6, 12, minus 0, negative 2. And I will get negative 6, 14. We would like to try the rest of the questions. Now I get negative 8 minus half of 3 times of the vector b minus c. So in this case, I'll need to work out one by one. This will become negative 1, negative 2. I cannot multiply the scalar multiple of half yet, so I'm going to keep it here. And this will be negative 6 and 12 minus 0, negative 1. Simplifying, I'll get negative 1, negative 2 minus half of negative 6 and 13. Now I'm going to multiply the vector by half. That will give me negative 3, and this will be 6.5. And we will get a total of negative 1 plus 3, that gives me 2. And negative 2 minus 6.5, 8.5. Have you gotten the answer? Next, we can also simplify the vectors without the column vector itself. That means we are going to write the vectors on a roller skates. So this question over here will have the vector A plus 2 times of the vector A minus B. Remember to put the roller skates on all the different vectors. If not, it'll become algebra and everything will be considered as 0 marks. So now I have my expansion, 2 times of the vector A and 2 times of vector B. And that gives me a total of 3A minus 2B. What about part B? I will have the vector A minus 2B. This is going to be negative half of 4B, and that gives me negative 2B. Negative half of 2C, that gives me negative C. Put everything on the roller skates and write them as a vector. So now simplifying the vectors, I'll get A, negative 4B, and negative C. So this will be the answer. Have you gotten the answer? Now up next, we're going to do a little bit of drawing. So take a quick break, a 2 minutes water break or whichever, to wash out your face and get ready for the next part of our lesson.